Okay, so in this part, we'll start to find the complete response for general RLC circuit. So actually, we'll try to find the complete response for RLC circuits. Complete response means it includes both the homogeneous solution or in circuit theory we will call it the natural response, which means that it doesn't involve any source, and also the particular solution, and in circuit theory we'll call it the force response, which means it relates to the source, the independent source or dependent source, no matter, or analog to a mechanical system is just like an external force. So let's go to an example. Okay. So 12 volt. Four ohm. 1 Henry. This is 2 ohm. This is a switch which is closed at t equals 0. ½ farad, like this, V, and this is I. So we'd like to find the complete response V and I for t is larger than 0. So we would like to find for both V and I. So first of all, we would like to check the initial condition. Check the initial condition. So actually, this is simple. For the I0 plus for an inductor is continuous, so it is equal to I0 minus. And for I0 minus, this is open, so there will be no current going through here. This is a capacitor for a steady state, so this is open, so it will be 0. It will be 0. And for V0 plus is actually continuous, and because the current I is 0, which means that this is 12 volt, 12 volts. So this node is 12 volts, this node is 12 volts, so as this node is 12 volts. So this is 12 volts. And actually this is an second order. This is a second order circuit, so we also need to know the first derivative of I and V. First derivative. Okay, so actually we would like to know VL. So for an inductor, it is something like VL 0 plus is equal to L d I 0 plus dt. So we can find that di 0 plus is actually VL 0 plus over L. And VL 0 plus is actually 0. Right. No, not really. Let me see. So let's check what VL 0 plus is. Well, for t equals 0 plus, this is 12 volt. There is no doubt. And I0 plus is also 0. So in this case, this is also 12 volt. And in this case, VL 0 plus is 0. Let me see. Yeah, di 0 plus is actually 0. So this is 0. This is 0. And for V, this is a capacitor. So we will have IC 0 plus is equal to C dV 0 plus dt. And in this case, dV 0 plus dt is IC 0 plus over C. And actually, I is 0A. So this is 0. This is 12 volt. So at t equals to 0 plus, this current will be 6. This will be 6A, 12 volt. And in this case, IC should be minus 6. So it should be minus 6 over over 0.5, 0.5, 1/2, which is minus 12 V per S, V per S. So actually we have this as the initial condition. This is also another initial condition. And this one and this one. So we can start to write a ODE describing this circuit. Let me see. So we can use KVL for the left loop. So we can write that 12. So this is 12, and this is I. This is I. So so this voltage drop is 4I. 4I. And for this one, it will be VL, which is L di dt. L is 1 di 1 di dt. Di dt. And for this one, this one will be V. This one will be V. Yeah. Plus V. This is the voltage drop for here and there. Yeah. So we'll get the first equation. The first equation using the KVL, and what is the next? Actually, we can write a KCL at this node. So this one comes from KVL, and another one we may use KCL too. KCL at that node. So this current is I. So we have I, and this current is C dV dt. C is 1/2, and dV dt. And this current would be V over 2. V is the voltage. V is the voltage here, and this is 2 ohm. So V over 2. So actually we have two equation. So let us try to simplify them a bit. So the first one will be di dt plus 4I plus V equals 12. Actually nothing to simplify. We can only write it a little bit better looking. And actually the second one similarly, we can write it like this: dV dt plus V, like this. So we can write that the second derivative of I will be 1/2 second derivative of V dt squared plus dV dt. So we just take the derivative. No second derivative, only first derivative. We only take the derivative of this equation. so that we'll get this one. And actually, we can substitute di dt and also I into here, so that we can eliminate I and di dt. So that di dt is 1/2 second derivative of v plus dv dt. So this is the first term, and then the second term 4i, so 2 times this one, so 2 dv dt plus 2v and plus v equals to 12. So actually we can multiply both sides by 2. So that this is 1, so that we have a second derivative of v, and then this is 2 times 1/2 1, this is 2. So 2 times 2 is 4, plus 1 is 5. So 5 dv dt. And 3 plus 1 is 3, 2 plus 1 is 3, multiply 2 is 6v, equals 2 times 12 is 24. Yes, it is correct. So we need to solve this second order ODE with external source. So actually we substitute the second derivative as s squared, and then the first derivative as s, and then the original function as 1, so that we have a characteristic equation like this, and we can solve that. S is equal to -2 and -3. Yes, yeah. So actually the complementary solution would be a exponential to -2t plus b exponential to -3t. And the Vp will be a constant d, because we have an inductor, which is we have a capacitor C, so we do not use C, we use D instead. So Vp, we can just substitute it into here. Second derivative will be 0, first derivative will be 0. So 60 will be 24. So we have 60 equals 24. In this case, D equals 4. Which means that V will be 4 plus A exponential to -2t plus B exponential to -3t. And we know that the initial condition V0 plus is 12, dV dt0 plus is -12. 12 and -12. So that we can take the derivative of V. So take first derivative of 4 is 0. And this one, -2a exponential to -2t. And then here, -3b exponential to -3t. So V0 plus will be, substitute 0 here, which is 4 plus A plus B, which is 12. And dV0 plus dt, which is minus 2a minus 3b, which is minus 12 minus 3b, not 2b. Yeah, like this. So it will be minus a minus b, 3. Okay, make it like this is fine. So for the first one, we can write it as a plus b is 8. So we can multiply both sides by 2 equals 16. So we add these two together. We will have add them together. We will get minus b equals to 4, which means that b equals to minus 4. And here we see that 4 plus a plus b is 12, which means that a is 12. So we get that v would be 4 plus 12 exponential to minus 2t minus 4 exponential to minus 3t v. So this is the answer. And for I, actually we don't really need to write another equation and solve again. We can actually see that let's see, I would be 1/2 dv dt plus v, which means that we know that t will be 1/2 dv dt plus v. Okay. Yeah, this one, I is 1/2 dv dt plus v. So actually v is like this, so we can calculate like this, dv dt. So first derivative is 0, this one minus 24 exponential to minus 2t, and this one plus 12 exponential to minus 3t, and then plus v. We have plus 4 plus 12 exponential to minus 2t minus 4 exponential to minus 3t. So finally, this is 4 over 2 is 2. And then this one, 12 minus 24. So minus 12 over 2 is minus 6 exponential to minus 2t. And finally, this one, 12 minus 4 is 8. Over 2 is 4. Something like this. So IT is this one. For t larger than 0, of course. Okay, so let's see another example. Okay. So for this one, voltage source 7 UT volt. So like the last one, UT is a step function. So it will be 1 for t is larger than 0 and 0 for t smaller than 0. So this is 3 ohm. This is half Henry. This is a resistor. This is a resistor. 1 ohm. VO plus or minus 1/5 Henry. 1/5 Henry. Yeah. VO. So actually, in this question, we'd like to find VO VO VOT for t is larger than 0. So actually for this case, you should be very careful because for resistor, not only the current and the voltage is the voltage or the current are not necessarily continuous at t equals 0. So so many inductor. So actually we can define this one to be I1 and this is I2. This is I2. And in this case, this is I1 minus I2. This is I1 minus I2. And I would be continuous. I'm not really sure whether it's a first order or second order. But, yeah, it would be second order. So first of all, we would like to find the initial value. We'd like to find the initial value for t smaller than 0. Then this source is a short circuit. It's short circuit. So actually I1 0 plus will be I1 0 minus, which is 0, 0A. I2 0 plus likewise would be 0A because for t is smaller than 0, the circuit will look like this. Will simply look like this. There is no source and this is inductor, so it is a short circuit. This is also short circuit. So there is no source, so of course there will be no current at all. I1, I2, there will be no current at all. And the next step, we will like to find the first derivative of them. So in this case, let me see. Actually, we need to find Vout0 plus. Actually, Vout0 plus is actually the voltage here. So we know that Vo0 plus is nothing but 1/5 di2 0 plus dt, and then we can have di2 0 plus dt is actually 5 Vo0 plus. And actually, what is 500 plus? So in this case, we'll know that we use the KVL. So that the voltage source is 7 volts. Equals 3 times I10 plus. Plus 1/2 di10 plus dt, which will be equal plus Vo0 plus. So we write the KVL for this loop. It will look like this. VL10 plus is 7 volts. So actually, we know that this term is 0. So this is 0. So we have 1/2 di10 plus dt plus Vo0 plus. di1 dt. And we know that I10 plus is 0. This is 0, and this is also 0. So I1 minus I2 at t equals to 0 plus is 0, which means that we know that VO 0 plus is actually 0. It's actually 0. Which means that which means that this one is 0. This one is 0. This one is 0. And this one is also 0. So that di10 plus dt is 2 times 7, which is 14a over s. So we have initial condition like this, and this one, this one, this one, this one. So we have got the initial condition. So now we can try to write the ODE about this circuit. Okay, so at t is larger than 0, we have 7 equals 3i1 plus 1/2 di1 dt, which is the voltage here, and also for V out, which is 1/5 di2 dt. So this is the current for that one, the voltage for this one. And actually we can also use the KCL at this node, which means that I1 minus I2 will be nothing but this voltage. This voltage is 1/5 di2 dt over 1. This resistance is 1 ohm. So this is over 1, which is itself. So so in this case, for the second one, we can write it as I1 equals 1/5 di2 dt plus I2. And for the first one, we can write it as well, can just leave it there. So actually we can take the derivative of this one, which is di1 dt, which will be 1/5 second derivative of I2 plus the first derivative of I2, something like this. And then we can substitute it here and here to eliminate I1. Eliminate I1. So first of all, 7 equals I1 is here, so we have 3/5 di2 dt plus 3i2, and then this one 1/2 or times here, so the next term will be 1/10 second derivative of I2, and then 1/2 of this one is 1/2 di2 dt, and then this is itself, so 1/5 di2 dt. Yeah, something like this. Then we can just multiply both sides by 10. Both sides by 10. Then it will look like it will look like this. This is 70. And then let me see. This is second derivative. So second derivative 1/10 multiplied by 10, so it will be 1. Second derivative of I2, and then the next one, first derivative, is this one, and this one. So 10 times 3 over 5, which is 15. And this is 5, 15, 5, 20. This is 2 plus 22 di2 dt. And then the next, this one, is 30i2. One fifth 5 2. Oh, not correct. This one should be, this is not correct. 10 times this one. This is only 6. 6 plus 5, 11. 11 plus 2, 13. Only 13, not 22. Oh, this is not 15. This is not 15. This is only 6. Yeah. So it will get a second order ODE like this. And so first we would try to solve for the characteristic equation. S squared plus 13s plus 30 to be 0. So we have s to be so s will be minus 3 minus 10. In this case, I2c will be a exponential 2 minus 3t plus b exponential to minus 10t. I2p would be c. So we substitute this one into here, second derivative with 0, first derivative with 0. So we have so we will have I30 I2p or 30c to be 70. So c will be 7 over 3. And which is 2.333. So in this case, I2 will be 2.33 plus A exponential to minus 3t plus B exponential to minus 10t. Something like this. So we need to pick our initial condition. I2 0 plus is 0a, and the first derivative is also 0. It's also 0. So it will be easy to handle. So first, let's take the first derivative of I2. So first one, constant is 0. And the second one, minus 3a exponential to minus 3t. And then the next one, minus 10b exponential to minus 10t. So I2 0 plus is 2.33 plus a plus b, which is 0. And then di2 0 plus dt, which is minus 3a minus 10b minus 10b, which is also 0. So in this case, we have so we can multiply this one by 3. So we have 3a plus 3b, which will be 7. And then we add them together. Then we will have minus 7b to be 7, which means b is minus 1. And then we substitute it here, so we have a to be minus 1.33. Oh no, this is 7. This is minus 7, so this is minus 7. So b is 1. So b is 1. A is minus 3.33. Should be like this. So I2t would be 2.33 plus minus 3.33 exponential to minus 3t plus exponential to minus 10t. But don't forget, we actually need to find V out. And V out will be 1/5 of the first derivative of I2. So actually, V out would be 1/5 first derivative of I2. So 1/5 first derivative of this one is 0, and for this one 10 exponential to minus 3t and minus 10 exponential to minus 10t. So the answer will be 2 exponential to minus 3t minus 2 exponential to minus 10t. It will be out B. Yes. Ow. Ouch. Okay. B will be something like this. So this is the end of this part.